And finally, we get to logic errors. These are the real problems. These are the ones that are going to keep you up at night. These are the ones that are going to make you want to pull your hair out. These are the ones that are going to make you want to quit programming altogether. That being said, these are also the ones that make you feel the best about solving a problem. These are the ones that are the hardest to approach, the hardest to solve, but the most gratifying. It's like that moment where you finally get a concept in a very complicated math class and you get that aha feeling, that feeling of satisfaction. But you have to get there first. Logic errors are tough. A logic error is an error that prevents the program from doing what it's intended to do, and it produces unexpected results. The problem is that the program doesn't crash. The program compiles fine. The program will complete as normal. But what it won't do is what you expect it to do. So, in the most basic example I can think of, imagine you're creating a program that's calculating the area of a rectangle. But instead of multiplying the length times the width, you accidentally add. Now, of course, that's not going to produce an effective result. So, for example, if you had a length of 2 and a width of 3, you would expect the result to be 6. But you'd get a 5. So you'd look at that, maybe scratch your head and say, what's going on? That's a logic error. Or something more complicated. Let's say, for example, you're creating a game and you have two objects that are passing through one another, but they're supposed to collide. Why didn't they collide? That's a logic error. So the program is still going to finish, it's still going to work, it's just not going to do what you want it to do. So what we're going to do is we're going to try and analyze this. So I'm going to show you a very brief example. On your screen here you see a very tiny program. It's to calculate the area of a circle. Now look at this and try and figure out where the logic error is. There's actually two, to be perfectly honest. First of all, our radius has a value of 0. So no matter what, this calculation is going to produce a result of 0. But let's assume that we give the radius a number. Let's say 5.5. And we run our program. Well, let's keep it something simpler. Let's say 2. So 2 times 3.14 is roughly 6.28 times 2 again. So you're going to have 12 point something. Now, if we run this program, we run it, we get 12.56 and a few other decimals. That's great. But that's not the area of this circle. There's a problem with that. This is not the formula for the area of a circle. That's the formula for the circumference of a circle, 2 pi r. We need to modify this. This should actually be pi r squared. We need to modify this so this is not a 2, and this should be pi times radius squared. Now we could do math.pow, or we could just write radius times radius. Either way, we'd end up with the same results. Now if we run the program, we're still getting, because we have a value of 2. Just coincidence there. Put a value of 3, we should get something a little bit more effective this time. That was a terrible example. We run it, and we end up with 28.27. So we've actually solved our problem at this point. That's a very basic logic error. Now, of course, what's going to happen in reality, you're going to be confronted with some major logic errors. They're going to be very frightening and very difficult to actually solve. So how do we approach these? So similar to runtime errors, the only way to prevent logic is by testing. You need to test your code. Test, 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 and test some more. It doesn't matter whether, the best idea I can come up with is this. You can have 200 people testing a video game for months and months on end. But as soon as that video game hits the wild and you have 1 million people playing it for a couple hours, they're going to find things that you never thought to test. It's just pure numbers. That's the way it is. So they're going to find problems. It's impossible for you to fully test a large-scale program like that. But we have to do the best we can. So what we're going to do is we're going to talk about those two examples we mentioned a minute ago, and we're going to try and figure out how we would resolve the issues. So the first example was the idea of the area being calculated with an addition instead of a multiplication. In that problem, it's simple to solve, because during the process of using the software, people would quickly see that the area is always smaller than it actually should be. So the natural place to look would be where the area is calculated. So you'd look at that, and eventually you'd see that you have the wrong operator on there. You have a plus instead of a multiply. That's a very simple logic error to approach. So in the second example, we stated there's two objects that move through one another. Now, they're supposed to have collided. This is an extremely complicated issue and can be a result of any number of problems leading up to the testing looking for a collision. So in this case, as in most logic errors, it's best to start at the end and work your way backwards. Meaning, find the code that does the collision test and examine the values of the variables at that time. Determine which, if any, are out of sorts. Now, once you know that there's a value that's wrong, you got to backtrack. You have to trace that variable backwards and say, where did it get its value? It must have got it somewhere. Where was it calculated? Where was it retrieved from? Why was that data wrong? And you got to work your way back until you find the source of the problem. It's not always going to be easy. So in order to solve a complicated issue like this, what we're going to do is we're going to use something that you haven't seen before, something called a breakpoint. And what this does, it allows us to modify our code. I'm going to quickly kind of change our code that you see on the screen here and go back a few steps. Okay, right here. So this is the program we were looking at during the last video. And all it does is calculate the pay per hour and display it on the screen very simply. Now what I'm going to do is I'm going to add something new in here, something called a breakpoint. Now all I have to do is somewhere on this blue bar on the left hand side, I got to find a line of code that I really care about, something that I feel like is meaningful. So let's do the line here where we read in the data, and right beside it on the blue line I'm going to double click. And what that does is it creates this little blue circle. This is called a breakpoint. Another way of thinking of a breakpoint is like a pause point in your program. The pause point will allow the program to execute as normal from top to bottom, but when it gets to that point, it will pause the program and switch to the debug perspective, or ask you to switch to the debug perspective, and you should agree to it. Now, it will only do this if you're using the bug command to run your program or the F11 key. If you're using the standard play, it won't do that. It'll skip it and it won't even bother trying to stop at the breakpoint. Now, what happens is, let me run this program here so you can see that. Yes, run it. And immediately it's telling me to go to that debug perspective. I'm going to say yes. And it's currently paused on this line. It has not executed this line yet. What it's doing is it's just waiting there for me to actually do something. Now, what I want to show you is all the things that we're capable of doing. From this point, I can actually put my mouse over certain variables and I can see the current value of that variable. Now, hours doesn't have a value yet because it hasn't executed this line. Pay per hour, again, doesn't have a value yet because we haven't executed this line. Now we can start doing, as I showed in the previous video, you could watch this data by selecting it, right click and add watch, and you'll see it appear up in the expressions tab over here. And that's fine, but maybe you want to do something more complicated like this whole concatenation down here. It's up to you. But the more important tab in this window is this variables tab. This will just tell you all the data currently active in the scope that you're in. So in this case, the scope that we're in is the main code here, this main subprogram. So any variable that has a value will display up in here. So how do I actually use this debugger? This is an amazing tool that allows us to do a lot of stuff. So all we're going to do now is we're going to look at all the different commands that we're capable of doing. So we already saw the fact that we can mouse over. We saw the fact that we could add it to our watch. But there's 3 keys that we can do different actions with. With the F6 key, we can execute the current line of code that we're on in full. So if I hit F6 right now, it's going to execute this line, but now it's waiting down here for me to type in my data. So let's put in 40. And I'm going to hit enter. And now it's on the next line of code and waiting for it to execute. We're stepping through the code. That's the term we use. We're stepping through the code one line at a time. You can see now up here in the variables tab that the hours variable has a value of 40. And again, we can mouse over the hours variable and we can see what its value is. Now this line of code still hasn't executed, so I can hit the F6 key again and it will execute that line in full. Now we can see pay per hour has a value of 17. There are two other commands that we can use while we're stepping through our program. So to illustrate this, I'm going to hit stop for a second, and I'm going to rerun it using the bug command, the debug command. And now I'm going to illustrate the other two. The first off, instead of using the F6 key, we can use the F5 key. And if we have a subprogram that we wrote here, it will actually do what we call step into. And it will actually go into that subprogram and step through that code one line at a time, as opposed to the F6 key, which will just execute the subprogram in full and remain on the same line that we're just on. Now we see that these input.next line and stuff like that, that's not something we wrote. If I hit F5 right now, it actually takes me to the code for the scanner class. That's not really helpful to me. I didn't write that code and I don't really care about it. What this allows me to do now is to illustrate my last key. So F6 executes the current line in full. F5 will go into the subprogram if there is one on that line, otherwise it just executes the line as normal. And then lastly, there's the F8 key. The F8 key will resume code execution. We can see that it's actually running, and down here it's waiting for me to do my input. I'm going to say 10 hours, and we actually get our result, $68 per hour. And I can go back to my main tab as I want. So we have F6, execute the current line, F5 to go into the subprogram or execute the current line, and F8, resume the program. I can actually have multiple breakpoints on my program. So here, let's try running this one more time. It's going to get to this point, and I am going to click F8 to just resume. And now the program's waiting on me to enter data. And now when I hit enter, again it breaks on the second breakpoint. It skipped this calculation line, which it stepped to before because I was using the F6 key, but now because I use the F8 key, it's going to run until the program's done or it sees another breakpoint. So this idea of stepping through the code is an extremely powerful tool to allow us to analyze all the values of our variables at any given time in the program. You're going to find this very valuable. And that's how we approach our logic errors.